Hello, welcome. This is now Edexcel's S1 June 2011 question 2. Now, this question is all about normal distribution. We're given that this, basically this sign here, well, I've tried to copy it on the exam, where it's x and then this little squiggly line n brackets mu, comma obviously 5 squared. Now what that means is x is normally distributed. That's what the x n square root of the line means. And mu is obviously represents the mean, but it's 5 squared. You have to remember the form. They like to tell you it in this form because obviously it tests not only that you can read it, but you remember what the form is. Okay, and it's mu sigma squared. Okay, and obviously sigma, you can quite clearly, now they could have made it harder and put that mu 25. I mean, you think obviously sigma is 25 when sigma is not 25, because remember the 3 standard deviations on either side, and to have sigma as a standard deviation, okay, that means you'd have plus or minus 75 on either side, and that's quite a big spread of data. Now there's nothing wrong with having that in a big range, but obviously when the fact that P's x is less than 23 is well over half, you can quite clearly see, unless mu is a ridiculously small value of minus 60 or whatever it might be, you wouldn't naturally have something like that. So if you put mu, sigma is 5 squared, then obviously you'd be wrong. But hopefully you can see that's clarified everything up. Now what we also need to do in any normal distribution question is draw a sketch. Now we know sigma, and you might want to write sigma is equal to 5, and obviously we're asked to find mu. Alright, so any normal distribution question you draw a normal distribution curve, which mine's very good. Obviously you put mu as the mean, and you put plus 3, mu plus 3 standard deviations, or mu plus 15 on the maximum over here, and mu take 15 on the minimum, okay, over on the left hand side. And when x is less than 23, so it's on the left hand side of 23, it's 0.9. Now obviously when we look at the probabilities, this is 0 to 0.5 is mu, and at the fully on the right hand side, everything on the left of that has got probability. The probability of 1 is everything here and half at either side. Okay, so because this is greater than 0.5, it's on the right hand side. So 23 is well over on the right hand side of mu, because it's 0.91921, which is obviously bigger than 0.5. So we have all that bit. Now what I do is generally sort of line it off, so either side. So this is 0.9192. Okay, so you can recognise that we're dealing with quite a big number here. Now what we don't know about this, well, the other thing, we've got an equation in normal distribution that allows us to work out mu, or is the formula, standardisation formula, is the z value is equal to x take mu, x take the mean, over the standard deviation. Now what do we know in that equation? Well, we don't know the z value, but obviously we're going to work that out. We know the x value would be 23, we don't know mu, but we know sigma, okay? So then clearly all we need to do is redraw this, clearly, to find the, we need to look in these distribution tables which are given in the booklet to find what the z value is. Now the z value, what is less than the z value is 0.9192 is the probability that the z is the less than the z value. Okay, so you might see it as it's the bigger table. Okay, so z is less than little z. Okay, and that's equal to 0.9192. Now, what I would do, because that's not a nice number, it's not 0.92, there's the probability that x is bigger than 23 is not 0.1, it's 0.088, okay? Because obviously that won't be it's not a nice number, so it won't be in the smaller hand of the table where you find out the probability that little z is bigger. Big Z is bigger than little z, okay, so it's on the right hand side. So you look for the z value which has the probability attached to it of 0.992. And if you look at that value, you will get the z value to be 1.4. Okay, so you redraw it as the maximums of 3 and minus 3, and you just redraw it. Okay, now we have the same probability here, and these 3 and minus 3 are the standard deviations on either side. Okay, so we still have the probability that z is less than z of 0.9192. Okay, so now we know z, now we know the x value, now we know mu. We could just sub it into this formula. Okay, so we know the z value to be 1.4, so we sub 1.4 into b z, 1.40. We know x to be 23, and we know mu to be 5. Okay, so it's just a case then of rearranging that. Obviously, I don't need to show you how you rearrange it, but you clearly just times both sides by 4, and then rearrange it to get mu. Okay, and if you were to do that, you would get the value for mu to be equal to oh, great. I thought it was one part. I'm looking at some other question. I do apologise. I can't believe I've just done that. Oh no, sorry. Yeah, what am I going on about? Yeah, there's 2 normal distribution questions here. I do apologise. Don't listen to me. That's correct. Okay, so you get mu to be equal to 16. Okay, so that is your part A. Now we're asked to find so this part B, you don't need to do much working out, even though it looks like it, but it's only worth 1 mark, and don't be deceived by that, like you were in question 1. Really, when you get a quick 1 marker, it's normally quite easy. So we're asked to find the difference, the probability that x is between mu and 23. Well, we know the probability that x is less than 23, we just worked it, well, we were told it, okay, it's 0.9192. And the probability that, basically, you could draw another sketch if you wanted to. Probably another sketch would be helpful. Okay, so we know the fact that the probability that mu is less than 23. So we draw a 23 on. We know that the stuff on the left hand side of that is 0.9192. But we want that x is greater than mu, okay? And we know when x is less than mu, that has a probability of 0.5, okay? So this hand is 0.5, and we want the probability between mu and 23, okay? And because the probability that x is less than 23 is 0.9129, and the probability that x is less than mu is 0.5, we want the distance between the two, okay? Basically, just that bit, okay? Then it's 0.912, 0.9192, take 0.5, which should obviously get you 0.4192. And that's your answer to part B. Okay, so really it was just thinking about it, and because we want x to be greater than mu, we want x to be greater than a half, but we want it to be less than 23. Okay, you don't have to put all the correct numbers in for mu, you will still end up with a value of 0.4192. Okay, so that's your answer to part B. Now question 2 was quite a nice and easy one, even though it was worth 7 marks, in contrast to question 1, which was worth a lot less, but as you can see, 1D really annoyed me because there was a lot of working out for only 1 mark. Okay, so as I said in that video, please let me know if you've got an answer for 1D. Obviously I did, but you know, I did it the long way around. Okay, so thanks for watching, and hopefully we'll see you in the next video, question 3.